Hi, welcome to this exciting video in which we will cover the evolution of Iron Man suits and focus in particular on the nanotechnology Mark 50 suit as shown in Avengers 3 Infinity War. What will be interesting is to compare the technology we have at our disposal today to make such a suit, and you'll be blown away with what's coming up, so get your feet up and popcorn ready and join us for a journey of inspiration that will evoke the engineer in you. On this channel Synergy Files, we aim to inspire people towards engineering and technology for a better, more sustainable world. Subscribe today to get all our updates for videos, infographics, polls, and much more. Science fiction has led the way in helping to materialize and realize many concepts, gizmos, and gadgets that we use today. In many cases, the ideas and drive to research is inspired by comic books and movies. Similarly, in the recent Marvel Comic Universe movies, Iron Man certainly has captured the imagination of many engineers. Iron Man's suit has continuously evolved through the storyline, having little capability at the beginning to becoming virtually capable of doing anything imaginable in its latest version. We saw the suit getting more discretized over time, or in other words, the total number of parts kept increasing. Not only that, but each part was given more and more autonomous functionality in addition to its assembled functionality. In Avengers 3, Tony Stark's latest suit, the Mark 50, is shown to be based on nanotechnology. The suit is said to be composed of numerous nanoparticles that collectively morph into multiple different forms when required. There are also redundant nanoparticles that get used if repair is needed. It has been said that the suit is made up of gold titanium nanoparticles, of which there are billions. So if we do a virtual teardown of the capability, we find the following. Number 1, the suit is shape-changing and can remodel itself. Number 2, the suit is self-assembling and self-repairing. And number 3, the suit is modular, that is, made up of numerous fundamental units working in tandem. To compare the nanosuit with the science and technology of today and to see how close we are to achieving this, we have to dive in the world of material technology and unpack the developments one by one, beginning with shape-changing materials. It is true that through nanotechnology we are producing remarkable products that we haven't been able to make with conventional materials. These products are more lightweight and yet more stronger. And in the new age materials, virtually every physical property from thermal to electrical conductivity to flame resistance has been enhanced. But as far as shape-changing ability is concerned, we will have to go back in time. Scientists had already discovered shape memory alloys in the 1960s. For decades, we've had the materials that can return to their original shape when heated. Nitinol, which is an alloy of nickel and titanium, is the most widely known material with shape-changing capability. There were other materials developed that could change shape in two distinct ways based on the level of heat. However, heat signal as an input is impractical and also inefficient way for many applications. Electromagnetic input signals have far more flexibility and workability. And so scientists have progressed on developing small-scale materials that change shape based on current or magnetic field stimuli. An example of this is origami robots that change their folds. They were developed both at Harvard and MIT. The robots change their degree of fold once electricity is passed. So yes, we have advanced in developing shape-changing materials, but instead of looking for shape-changing monolithic materials, the more effective way is to have small building block materials that can rearrange themselves and take different forms. We now explore the second level of functionality as seen in Iron Man's nanosuit, which is the suit can self-assemble and self-repair. In simple words, we're looking at making things that make themselves. At the MIT, scientists have been able to make self-reconfigurable blocks called the M blocks. The objective of the research was to design robots that are not just single tasks but have the ability to change configuration based on the task requirement. Interestingly, the M blocks are able to achieve different types of motion that include the ability to rotate and jump with remarkably simple mechanism that uses a spinning wheel which is completely encased. So yes, the technology is there, but it is in the embryonic stage. It is a far cry from Iron Man's suit parts that can not just move but fly and self-assemble. As far as self-repairing ability is concerned, we have been able to make a certain type of fabric and a certain type of concrete that are self-healing, but their ability to repair is limited. This takes us to the final and most complicated functionality, which is the extreme modularity, meaning hundreds and thousands of parts both work separately and combiningly. Each part functions as an individual robot and can also work in tandem with other robots. In nature, we find various living creatures working in harmony with others of their kind. Ants are able to carry much greater loads when working together. Fishes are able to evade prey. Birds are able to fly long distances. If we are able to develop machines like that, we would have the best of both worlds, that is, the precision of one and the power of the collective. But how far are we in doing this? There's an entire field of technology called swarm robotics that focuses on the collective behavior of autonomous robots. Scientists have been able to produce swarms of robots that are not only ground-based but also aerial. Programming is the key in making them work together in addition to their individual functionality. Social insects are being studied in detail to characterize swarm behavior. In fact, swarms of micro-aerial vehicles have already been tested in tasks of autonomous surveillance, plume tracking, and reconnaissance. There are a few things that become clear when looking at all the information that we have covered so far. First is that the smaller the fundamental unit, the more versatility of the larger combined unit. In the human body, an individual biological cell does not possess the ability to walk or jump, but collectively they allow us to do so. Likewise, in birds, individually cells cannot fly, but they achieve that ability when they are working together. The information for cells on how to function individually and collectively is recorded in the DNA. In machines, we have to store that information through program code on microchips. So to what extent in scale can we go down when we create swarm robots? Well, we haven't reached the level of nanobots, which are the machines that should range from 0.1 to 10 micrometers. So nanobot science is still hypothetical. What we have been able to achieve though is to manipulate plastic beads at microscale to replicate gears. In our previous video on Iron Man, which focused on the initial versions of the suit, we established that with the technology available today, we can nearly achieve almost all its functionality, but high power requirements and energy storage is an issue. When we look at Mark 50 nanosuit, we are still decades away from making something even close to it. Machines that can make themselves, program that can reprogram themselves. We have been able to take some tiny steps towards this technology, but there's a long way to go. The beauty of Iron Man's Mark 50 suit is that it is made up of modular units that can self-assemble and can reconfigure, meaning it showcases different strands of technology coming together, namely robotics, material science, and artificial intelligence. In order to be able to produce such a thing, we need to learn from nature, as it has been able to make self-producing, self-healing, programmed life forms that go about their business in the most efficient way. So, what are your thoughts about what we have covered? Please discuss any ideas that you got from this video in the comment section, and as usual, if you learned from the content, make sure you hit the like button. Please do check out all the other videos on Science Through Comic Book series. Thank you for your attention.